how do you call that when we have 3 points, ellipses. Where was this again? Oh, well, I guess it's not really needed to resume on that. Anyway, I've been working on it and I finally fixed that part. The fix itself, where was that? I guess we could go back into C9 parser to have a look. It was really, yeah, I think it was really in this part when you resolve the template class name and so on. I added this so that you would first not just discard all your arguments, return an empty bracket like that, so no argument name. So you would keep those 3 points, in fact. Or actually, you would just return that you could not pass your template. Let me see. In fact, we should have a mention of this in our log file right now, but not core, or rather the Qt one. Args. We have this one. I think it's actually not taking any arguments in some cases. And we've covered all of them. Anyway, the thing is now it's in fact working. I made quite a lot of additional changes. Not sure how I could go through all of this. It's not really needed. What do I have? I think I've also, this is a short mention of it, but I have some additional, well, not real details, but yeah, I also had a case where I needed to, I tried to force parsing some template classes. So this is again around this location, and you could have a case where, yeah, you would want to parse a class template. So it's this additional value. I tried to set this to true. It's actually working when you set this to true also, but only partially, in fact, because you would reach this location, then pass your class, and this is then used when you have to go through all the child cursors for your current cursor, because we have this mechanism where we actually check if this cursor is inside the include files that we really want to parse or not. So this is to avoid parsing basically everything from the runtime, C++ standard libraries and stuff like that, because that would really take too long in the end. But there was a case here where I thought, okay, I'm going to inherit from, I don't know, I think that's the case where we had std integral constant. So I thought maybe we should try to parse that one anyway, even if it's not in an appropriate parsable location, I would expect. So I use this force parsing, and I would indeed parse the template, but then it would also not yet really create the template instantiation corresponding to that specific template and the instantiation parameters that we would really need. So you would end up with this, for instance, I don't remember, but it was somewhere near the end of that, maybe the top or something like that. I don't remember which one was using it, but you could end up with the parent here actually using this integral constant class, but the actual class would never really be defined or registered in the state. So I didn't even try, but if I was to try to build the module and try to load the bindings, there would be an error when the Luna system would try to find the parent to inject the parent functions inside those children classes. There's certainly a way to fix that, force generating the classes for those additional template for which we forced the parsing already. But I thought, okay, what's the point? I have absolutely zero interest in getting access to this integral constant parent. So when this happened now, I'm rather just, yeah, ignoring this parent again. Because yeah, you would try to parse that template, and then I would check if I actually found any kind of template parameter. And if I really found nothing, zero, then it must be because I actually didn't pass the cursor itself, because otherwise there would be at least one template parameter. And so yeah, we just set this back to nil to avoid any additional processing afterwards, and we don't process the base any further. So yeah, that was a point concerning the unreachable template location. So I'll try that, but not really useful. Advanced resolution of template class parameters. What do I mean with that? Yeah, I guess it's basically this part also, because when you are to use a template now, you would first really get access to the template ref cursor, and then from that ref cursor you get the actual template cursor, and you use that to find a name for your full template. And if you have a name, then you would extract your template name and the arguments for that name that you have read from the cursor, where you have the definition of the template. So you're not really using those args here that you were parsing, because maybe you have default arguments, stuff like that, so you don't get the complete list of actual template parameters from the real template. That's why we redo this here. And then yes, I go with the usual mechanism where I get the parent namespace, and from there I try to pass the class template using this cursor and the namespace that I have as a parent. So yeah, what was I saying? This is basically working fine, and now we could no, not this one. I really need NVL bind Qt. So what else did I change? Okay, yeah, there was another thing I fixed, which was noticeable. But this was a fix actually in the sources for the C-line module. And this was concerning C-line itself for the CX type, I believe. Yeah, actually, I'm not quite sure why, but there was a problem here when I was trying to get template argument as a value. Every time I was, for instance, expecting a value of, I don't know, say it was a 0 or a true or whatever, this string would not be retrieved correctly, and it would not be ending with a 0 character actually. So you would get additional messy characters. So I finally fixed that somehow, because now I'm using some kind of intermediate string to really retrieve the buffer size. I think this is a key before I try to create a dump from the data. Otherwise, I would be creating a dump with the buffer data directly, but I don't know why. It seems that this buffer is not in fact initialized to 0. I tried also to initialize that to 0, but without really checking what the sources are doing. So yeah, it didn't work out of the box anyway. So yeah, this is getting a bit better from that perspective also. Anyway, the bindings are generated. There's nothing changed here concerning Qt because I already committed the changes and they were all acceptable basically. It's also compiling, but now I am considering another point, which is to regenerate again the bindings for core, and that's where things are getting a bit tricky again, because as you can see here, I'm with the new generation, I'm removing this vector of bool. I'm removing the complete class here for vector of bool, and if we go there, we now have our ref vector using ref object as parent, but not anymore the vector of bool. Same thing here for vector of float, so that's not good. And if we check in the bind core, we have now this ignoring type alias template declaration cursor for our base class, the one we are interested in. And yes, that's because when I was working on Qt, on this part, basically there are cases where you would get your full template name here from the cursor to be an empty string. And in fact, this happens currently, I think, all the time when you have an alias template. I guess we could maybe have a look at the AST for Qt for that. So if we go in, no, not there. In the bindings for Qt AST, we are probably going to find that somewhere. So for instance, here, that would be the name you get as full name, which is empty, so not good. All the time it's empty. In the case of Qt, I thought, okay, I really don't need to push it further, so let's stop here and just, yeah, give up. But now I realize that that's not going to work. We need to really process the template anyway, find it and process it, because we need that for our NV vector, at least. Which means that then this could also lead to additional complexification for Qt, so we have to regenerate the bindings for Qt and see if it's not breaking something additional or stuff like that. But for now, let's focus on the core module itself and try to see what we should do here. So first, let's go into some analysis of the AST maybe. Or what I should do is try to use the AST for core, so at least that would be closer to what I really want to handle. Right? What should I look for? Maybe NV vector. Okay, wait. So we have this. I guess we are in the namespace NV. Yes, NV. And we have quite a lot of type alias template declaration, and I think that's because it's coming from my container definition that I'm using here. So in NV, I have a string, list, map, and so on, and vector is here. So it's indeed a template type alias. So basically we found that one. All right. So what should we do with that? From this type alias template declaration, we can find already the template type parameters. This are what I'm supposed to look for, right? Yeah, we have two cases, either the non-type template parameter, which can be added also, or the type parameter, template type parameter, which we are adding here. So if I were to parse this cursor, I would still get the template parameters. Okay, it's just that I'm wondering if okay, let's go down again. I would have a problem to pass a name because I don't really have a full name for this template. That's a thing. That's a problem I need to fix. Where would I get the name for the template? Template class, I mean. Type alias declaration. I think that could be the one. So whenever you find that, type alias template declaration, maybe we can expect to find a child which is a type alias declaration. So let's see if this can be generalized a bit. For instance, for deck here, you have your type alias declaration, and from that you could retrieve a complete name for your template. All right, bool constant. So you have type alias declaration std bool constant. So it seems to be consistent. Type alias declaration, yes. And in fact, even more interesting than that, we have the template ref in there. Yeah, no. I think this is what we need. Even if I'm not absolutely sure about that. Let's just check for the one we are really interested in. So we have, for instance, this NV vector, or there was the NV map, maybe. So NV map. So we will find a type alias template declaration for map and no full name here. But if we search for the type alias declaration in there, we will have the NV map. Sounds fair enough. So let's try that and we'll see if it's working fine or not. So what should we do? No, we should enroll. So check if we need to enroll type alias declaration here. Basically, even before we try to get a full name, we should not do that here. So we should do rather if cursor get kind is a ceiling. I mean, do we have cursor type? Cursor kind. Yeah. So type alias template declaration. In this case, we need to do something different. We need to find. Basically, we need to set the cursor to the first child cursor. So we say retrieve type alias, yes, declaration child. You know what? I'm starting to use this a bit too much, I feel. Oh my, am I really doing this? Yeah, I seem to be doing it. So you know I'm going to use here local CK, and that's going to be the C-line cursor, kind of. That's actually even something I could consider pushing at the top of the complete module, because I'm using that all the time. Come on, what am I doing? This one I will remove. So that's cursor kind. Hopefully I'm not breaking anything. Back to our modification here now. We need to find the first char, which is an instance of type alias declaration. And well, now again, we really expect this to be a valid cursor at this point. So check cursor is different from nil, and cursor is null. I guess we have is valid also. Yes, not absolutely sure this is exactly what I think it should be. So let's check is valid. Oh, we're checking a couple of things. Yeah, that's probably something good to do. So we need this cursor to be valid. Invalid type and then from that type alias we may retrieve the full name, at which point again the full name we would expect it to be valid. So this part will go away, and we can maybe add an additional check on the name. Oh, wait a second. I don't know what I should print there. You know, to type, what can I display? Get full name, I don't know. No, I mean, that's the same thing. Stupid me. Get spelling, if there's anything in there. Get spelling is actually what I call CNAME above. Okay, so, okay for this point, but now, thinking a bit further, if you look into this, what we really have, when you go into type alias declaration and you get the full name of it, is this. In the colon map, we don't have any template parameter provided there. You would need, in fact, That's crazy because wait, you have this type alias declaration, so you want to use this kind of name. But if you want to get a list of the parameters, you will need to search for a template ref inside this type alias declaration. And from the template ref, indeed, the full name would give you the full list of arguments that you need to use for the template, or something like that. Yeah, you see, for instance, here we have nv list, but no parameters listed here. And if we search for template ref, we get this additional list, which mean, oh my, that's tricky, which mean that if we find this, before we go in there, we should store like a replacement name. In fact, replacement name would be, well, I don't know what's the name. DBL name, am I using that? That's what I would pass otherwise, and what I would like to override. So you can use that. That's actual DBL name. Alias, yeah, alias, that makes sense. So alias, that's something, or TPL alias. You would set this to nil by default, but if you go to this point, that's where you would store TPL alias to be what you have as full name for your current type alias declaration. Right? So now you have something set for that. But then if you want to get the arguments, which by the way, I don't think we really need to do, because if we go to this point, we're just using that to check if we can proceed to display a debug message. And yeah, to do another check that the parsing was done correctly in the end, but it's not critical to us. So you could maybe do without this part, but I'm trying to be complete on this process, so I think that's a good step to take. So once you have the TPL alias, which you have extracted from your type alias declaration, you want to go one step further, and you need to find the first template ref that you have in this cursor. So you would do cursor again equal cursor get first child, and from there you would try to find your template ref. And again, you expect this template ref to be valid cursor. All right, and next, from that cursor, you would try to extract a full name. Will now pass template class. So you have your full name. Oh, wait, that's another tricky issue. Oh my, oh no, actually, it's really this class that you want to use for the parsing, because that's where you would have actual functions and so on. So that's good to take. So if you follow me, we are now on this template ref, so you would have access to std list. So that's fine. Except that, yeah, when you do that, you would produce TPL name here, and you would then get parent namespace. At this point, well, wait. TPL name is going to be std vector or std list. And you want to replace this with the alias if you have one. Oh, well, think about it for a second. If you have an alias, do you want to replace it? Or do you want to add this as another name for a type? Except that we're talking about class templates here. We don't really have types at this level. Only virtual types, but it doesn't really apply, I believe, the way I see it. So let's just try to use the alias that I have and discard the name of the base class template. So what we would do is if TPL, I mean, you could just do TPL name equals TPL alias or TPL name if there was no alias provided. From that really final name, you would extract the parent namespace, which gives you a namespace. And yeah, when you do the parsing, the initial idea was you don't provide a name for the class template because it's going to be retrieved directly from the cursor itself. Except that it's not true anymore if you look at that, because if you proceed this cursor, you will get the template class cursor for std list, and you don't want that. You want to call this nv list, or actually that would be just list, and you want that to be capital list in this namespace. So what to do? You must provide your class name here. And what should be this class name? It should be what you can extract as final name from this TPL name. So you know what? I feel when you get the parent namespace, you could extract the name at the same time. TPL name again. It's just that it's not provided yet, so we need to fix this part. First, I need to check where I use this function. So only one location, that's good. And in the definition of this function, I'm returning this, but also, can I provide an additional return value here? Well, that would be another string. Name of, yeah. And this you can retrieve when you remove the last entry from the table, so that I guess you could call that again CL name, because you're not going to use it afterwards. So you would return namespace and CL name. It seems to be accepted, because if you don't do that, it's going to tell me, yeah, should return two values. All right. So now we have this update in the get parent namespace to return our two values of interest, and then you get the TPL name, which is what I call class name here. So let's just call that class name instead, and you would use that for the naming of the class template object that you will create when doing the parsing here. Then when it comes to the number of arguments, you should have something that is not 0. And so you expect this to be the same count as what you have in args, which is what you retrieve from the template name here. And the template name came from the final cursor that you retrieve, which is a template ref. And so the template ref should have the appropriate list of template arguments here in the full name. CK is not written like that, so small fix. And now, where are we? Now I expect to fix this issue that we had with the NV vector. Yes, this one should not happen anymore, so we'll see what's the result of that when we generate the bindings for core. No error. Oh, come on! Unreachable cursor for base class. That makes sense, because I'm requesting the system to parse std vector to get the content of that. So back to the initial concern where I said, okay, I'm going to try to just not use this this flag that I'm adding to force the parsing. Sounds like we kind of need that. But it's funny in the end, because we have in our case here in the container, come on, container.h, we have this definition for NV cursor, so that's definitely, yeah, this file here is reachable for us. It's part of the sources that I want to parse. So on one side, the name of the class itself is something that is possible, but to parse that, I'm going to go there, and this one is not possible. I have no idea what's going to be produced here with true. So let's see. Well, why not? Oh my, that's tricky. Oh, wow. Oh. What on earth is this? Where are we going? Problem is here, ignoring entity defined in this file. Ouch. Yes, okay, you know what? Let me just think about that for a moment. Okay, so I decided to investigate a bit on the error that we just got produced concerning this invalid base, invalid type base name. Why? Because, yeah, I kind of want to fix the bug anyway. Even if technically we could just avoid this. We don't really need to go and parse the std vector template. We already have an additional mechanism to generate the function we want from this template anyway. So in fact, parsing this is probably going to generate more conflicts down the road. So maybe not the best idea in the world, but because I'm a bit curious, I need to figure out why this is going wrong. And the thing is, when I disable this, when I re-enable this debug output here, we see the row name before we do any kind of processing. And if you do that, you see that we get at some point this output. So we're considering a type which is the std identity on alloc inside this template, and then again inside this template. That doesn't make sense. In fact, we really expect to have this at template name only once in the type names. That's why we're going to extract the base name here, taking the string from 1 to just before the last argument of this character. So we're going to take this, and in this part we really expect not to see this part, final thing here, which is a TPL context. TPL context is indeed starting from this base name at the index where we found the last at. So question is, how could it be we got to the point where the base name here as this dual NV vector context? So let me try to think about that and see if I can answer this question. Okay, so I think I have an explanation now. I added some additional debug output, in fact, in the get row name here, and you have multiple paths here to return different results. And at some point then, we would reach one of those paths, which was the first one, in fact, in there. You would have a base type, and you would return the name from the base type as row name. And when you do that, where was my get name again? Okay, so when you do that, you already have a context in there. The thing is, there is a type inheritance trees, if you want. So this const std blah 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 is actually inheriting this one somehow. I mean, no, not the type, but the one without the const, at least. I don't know where exactly this is coming from, but pretty sure we have it somewhere. So renaming this type to const blah blah blah. No, that's not what I mean, but anyway, yeah, we have that somewhere. So if at some point you have a base class, so let's say that's the version without the const here, then you call this and you get the row name from the base. You're going to get, what is the name of it? Identity alloc. You're going to get identity alloc at NV vector, because this is the base is already a template. So you would get at NV vector here. And so your context is still NV vector. And you would check, okay, if this is a template, I get this base name. Oh, wait. Well, could it be one of them is going to be a template